Good afternoon, one and all present here. My topic is mechanical properties of material. I'm going to be discussing here. So, mechanical properties of material is common for both engineering, that is, mother of engineering and father of engineering. So, mother and father of engineering is nothing but it is a both common topic for and basics for civil engineers and mechanical engineers. Okay, before going that topic, a small introduction about properties. So, what is meant by property? Property is a qualitative or quantitative measure of responses of materials to externally imposed conditions like forces and temperatures. Okay, actually, there is a material when we are applying some force, though, what is the character of material will be changed. It may be a qualitative or it may be a quantitative. So, this is known as a property. The second point is the practical application of engineering materials in manufacturing depends upon the knowledge of their particular properties under a wide range of conditions. So before going to manufacture any product, without knowing the property of materials, we can't use. So that is the point number 2. So what are the classifications of material property? There are 4 classifications of material property. So first one is a chemical property, physical property, mechanical property, dimensional property. So chemical property, what are the chemical reactions of material like this? Physical properties, what are the density, Poisson ratios, conductivity, so like this. Mechanical properties, strength, toughness, stiffness, so like this. So dimensional property means what is the changes in size, shape and extras. Okay, so here we will discuss about mechanical properties. So what is meant by mechanical property? So mechanical property describes the behavior of material subjected to external force. When we applying some external force to the material, so how it will behaves. So that is the mechanical property. The mechanical property of materials, it will provide the basis for predicting behavior of materials under different load conditions and designing the component out of them. Before going to design any product, we will applying the different forces and what is the behavior of material will change. So that will notify. Next, classification of material property. So strength, elasticity, plasticity, ductility, malleability, stiffness, toughness, hardness and fatigue. So these are the major classifications of mechanical property of material. So first, strength. Strength, it is the ability of material to withstand the load. For example, steel and RCC structure. Steel structure and RCC structure. So RCC is nothing but reinforced concrete columns. So see the figure number 1. So there are 2 humans are pulling one material. It may be a 2 equal force or unequal force. It depends on the humans. So that material withstand the load of that humans. So next figure, there is an animation. The one man jumping on the structure, one structure or jumping on the material. The material should withstand the load. So this is the strength. Next, elasticity. So elasticity, it is the power of coming back to its original position after deforming when the stress or load is removed. So when we are see the figure, it was easy to understand. So there is a human jumping on the one material. The material will deflect. So after the human came up, the material came to its original position. When he again come down, it will go down. So after removal of material, it will come to its original state. So that is the elasticity. So next one is plasticity. It is the ability of material to change its shape permanently. So after removal of load. So see the figure. So there is a one form of material is melted and poured into the mold and make it as another form of material. So this is known as a plasticity. So for a better example for elasticity and plasticity is So all of you know about a rubber band. So when we applying or when we pulling the rubber band for some particular force, when we release the force, when we release the load, it will come to its original position. So this is elasticity. When you are giving the continuous load, continuous pulling, so after some particular load, it will break and it cannot come to its original shape, is known as plasticity, and length of the rubber band also increased. So this is plasticity. So for I am saying for better understanding purpose only I am saying. Next, ductility. So ductility is ability of material which drawn into a thin wire. It is ability of material is drawn into a thin wire. So there is a material is, see the animation. So there is a material, the human giving a two equal or unequal forces to the material and they are pulling. It will become like a wire. So this is the best example, and see the figure number 1 also. That figure, there is a copper rod is pulled by, they are pushing through the carbide die. It will come like a copper wire. So ductility for best example, mild steel and coppers. The electrical copper wires are made by this method only. Next, malleability. So malleability is, it is the ability of material to drawn into a thin sheets. So it's like a thin sheet is known as malleability. For a best example, gold. Gold can be readily rolled and hammered into thin sheets but can be drawn into a wire. So see the figure. The gold biscuits or gold plate, by using hammer and heating, it will become a gold coin or something shapes, something sheets. This is the one example, and another example, by using that animation, there is a material heated by human, at the same time by using hammer it will become a thin sheets using the hammer blow. So another best example for easily understanding purpose I am saying, wheat atta to make chapati. So there is a round wheat atta is rolled by that chapati making machine or that chapati roller. It will comes like a thin sheets. Just I am saying for understanding purpose only, for malleability, this example. Then hardness. It is the ability to resist the scratching, indentation, wear and tear. So in figure number 1, so there is a the human scratch on the floor, maybe a scratch on the tiles. So due to that friction, there may be a wear or there may be a tear, there may be a scratch. When the material will resist means it is a hardness material. The best example of hardness material is diamond. So glasses will be cut by diamond tip tools only. So that is available in figure number 2. So that between the fingers there is a diamond tip tool and make it they are cutting to use the glass. Next, brittleness. It is the property of breaking the material without permanent distortion. That means, see the figure number 1, it will clearly, it will shows clearly. So first one is the ductile material. It will come, there is a neck formation, then it will come like a wire, then after that the material will be break. So see the brittle material, it will be cut after some particular force, it will be cut without any distortion or without any disturbances. So for a better example I am saying, this is not an exact example, I am saying for understanding purpose. So if you take a biscuit, if you give load or if you give load, it will become cut. So this is the best example for brittleness. So for brittle materials example is glass, cast irons. If you put glass from particular height, it will break. Next, stiffness. It is the ability of material to resist the deformation. So when you are applying the load, it cannot change. its size and shapes is known as stiffness. For example, on the steel spring or spring steel. Next, toughness, ability of material to resist the shock load. So see the figure, there is a human, by using hammer they are giving the shock load, just one blow. So there is no changes in shape and dimension, it will resist the load. This is known as toughness. For example, high speed steel. So high speed steel is mostly used for to making for tool purpose, machine tool purpose. When we using the tool for machining, when we are giving depth of cut 1 mm, 2 mm, 3 mm. So toughness material is mainly used for to making the manufacturing of tool purpose. So types of load. So there are the 4 types of load based on mechanical property. So static load, dynamic load, shock load and impact load. So there are 4 types of loads based on the mechanical property. Static load. So the load value do not change with respect to time is known as static load. For example, machine weight. So when we kept machine at particular floor, so there is no changes in machine weight with respect to time. The machine weight will be a common one. Next, dynamic load. So dynamic load, it changes with respect to time. The load value will changes with respect to time. So for example, cutting force, when we giving the depth of cut to the tool, so the force may be vary, which depends on human beings and depends on time. The human may be tired, means it will give slow force. The maybe human may be in very active, it will give rapidly and randomly high force. For best example, for it's not a it's not an exact example, I am saying for understanding purpose. The 2 men are running on the ground at starting for 10 rounds. For 10 rounds, we take it as 10 round. First 5 rounds he will go very fastly. So after 5, so for each round the speed will be decreased randomly or with respect to time. So this is the another example for dynamic load. Next, shock load. So shock load will act suddenly at a time. For better example, so during car driving, when we applying brake, so there is a load and reaction between tire and road. So this is a shock load during the brake apply. So next, impact load. So impact load is also a one type of suddenly applied load, and it act with some velocity. For example, so hammer blow. So hammer blow is applied suddenly with some velocity. It is known as impact load. Next, force. So force is nothing but force F is equal to ma. So force is the product of mass into acceleration. So see the figure. So there is a foot, human foot will hit the rubby ball. The rubby ball will move with some speed at particular direction. Okay, so the load will be given by the foot, force will be given by the foot, the mass, the rubby ball is the mass. The mass of the ball will move with some velocity at particular angle. So this is the acceleration. So another best example I am saying, so all of you know the cow. When we beat cow, for example, maybe a X boson or Y boson, the X boson will beat the cow. What is the sound of the cow after beat? Ma. It will give a sound ma. So ma, M-A. So the human will beat. the human beat is the force, then the cow is the mass. So because of that beat, the cow will move some direction with some distance is the acceleration. So this is the understanding purpose I am saying for this example. So types of force based on the mechanical properties. So there are 4 types of forces. So one is the tensile force, compressive force, shear force and torsional force. So tensile force, so see the figure, tension force or tensile force, both are same. So there is a 2 equal or unequal forces at the end of the material, pulling forces, 2 equal and unequal pulling forces at the end of the material is known as tensile force. Due to tensile force, the material length is increased and thickness will be reduced. And next, compressive force. So 2 equal and unequal pushing force given at the both ends of the material is known as compression force. So see the figure number, that yellow figure. So due to that compression force, the length will be decreased, the thickness will be increased. Sometimes it may be a bending. Next, torsion force. So torsion force is nothing but at the both end there is a twisting force is given to the material is known as torsion force. The best example for cloth washing. So there is a during cloth washing and finally to removing of water from cloth. So example for in Tamil word we can say murukkrathu, that means thuni puliyrathu. So like this. So in shear force is nothing but there is a side force, 2 equal and unequal side force given at the end of the material is known as shearing force. Due to shearing force, the material will come to a particular angle, that means it moving like a slope. So the same figure there is a one changes in the figure, shear force. So in the shear force there is a 2 equal side forces are given. Due to 2 equal side forces, the material will be break at center point. So for better example easily to understand, there is a paper. If you take paper and giving 2 forces to split up the paper, so that is the one type of shear force also. The another for understanding purpose I am saying, for a child ear, so we have to pull the child ear. So that is the one type of so ear will be fixed. So at the one end we are giving the side force. So next, tensile test. Okay, before I am going to tensile test. So up to this we seen. So what is meant by property? What are the classifications of mechanical property, and what is meant by mechanical property? What are the classifications of mechanical property? And after that, what are the types of load based on mechanical property? What are the types of forces based on the mechanical property? We seen. So there is a material we don't know. So how to find material property? We don't know how to find material property. So based on some test, we have to find the material properties. There are many tests are available. Here we have to see only one test, that is the tensile test. So tensile test is mostly used to find out the strength of the material and also used to find the toughness and hardness of the ductility of the material. Okay, so this is the main use of the tensile test. So see the figure. So there is a moving crosshead and in between there is a specimen and there is a load cell. So one end of the material is fixed, specimen is fixed, and another other end is fixed with crosshead. Then moving crosshead come down. So there is a load is given to the specimen. It will come with some load, come down with some load. So material will be stretched. Okay, see the figure. So L0, so that is the original length of the material. When we are applying the force, the cross head will move down means, so there is a force acting both side. The length will be increased. Again the figure, the length will be again increased. In the third figure, in the fourth figure, the neck formation will be formed on the material. So after the neck formation, the material will be broke at the maximum capacity of material. So at the breaking point, so that load will be a breaking load or ultimate load. So after the breaking, so final length will be measured. So this first one is the L0 is the original length, so LF is the final length. Okay, by using this two length, how we will find the material property? So by using stress strain curve. Before I am going to stress strain curve, I will explain what is meant by stress and what is meant by strain. So stress is nothing but when we are applying the force to the material at particular area, so what is the reaction? So that is the stress. So there is a formula for stress. Sigma is the stress, is equal to F into A. F is the applied force, A is the area when we are applying the force. So strain is nothing but strain is the ratio of or change in dimension of the object to the original dimension of the object is known as strain. So strain is used to measure the dimensional change of the material. So see stress strain curve. In x-axis strain, y-axis stress. So between the region origin to that B up to B, so there is the material will be in elastic range. So elastic range means we know when we are removing the load, after removal of the load, the material comes to its original state. It is the elastic range. So after B to C, so within B to C, the material will be in plastic range. So after removal of the load, it cannot come to its original shape. So that is the B to C. At point C, there is a ultimate strength. So there is a ultimate load. That is the maximum load it can be withstand by the material is known as, that's at that point C. At point C, the material will start the necking. It will start the neck formation will be start. Then after C to D, at point D, so within point D, the material will be get fracture, material will be get break, material will be get break. So this is the stress strain curvature. So from this graph, the same material up to origin to B, it is in plastic range, B to C is in plastic range, C to D, it is in neck formation, then material will be break. Thank you.